Good afternoon, pilot teachers, and good afternoon, students. Okay, thank you. Sit down. Our lesson today will see us look at the introduction to Continental Drift. And for our work on Continental Drift, we'll look at a little bit about that particular theory or concept which was developed and the evidence that actually surrounds that particular theory or idea, which is referred to as Continental Drift. Okay, we're looking at our information on what we have covered so far on the Earth. And yesterday, we found out from our readings in our booklet that the Earth is actually a zoned planet, and there are 4 major zones that can actually be identified. And those 4 major zones are biosphere, which is the zone of life, hydrosphere, the zone of water, atmosphere, the zone of air, and lithosphere, which is the zone of rocks. And I mentioned also that we will concentrate mainly on the zone of rocks, which is the lithosphere, as our study on the physical geography booklet will concentrate on looking at the many features, physical features that are formed on the planet Earth, and the reasons or how those features have been created and how they have changed over time. We go back now to the homework that you are supposed to have actually completed. And if you look at what you were supposed to have completed, you're supposed to do a research and to find your information on how you think the Earth was actually formed. And you were supposed to also ensure that that information is to do mainly with the scientific explanation surrounding how you think the Earth was actually formed. So for the first perhaps maybe 5 to 7 minutes, what we will do is I'll go around the class and we'll see if a couple of students can read out what you have actually researched on and what you have written about how you think the Earth is believed to have been formed scientifically. We'll hear from you first, and then later I'll put up a summary of the main ideas that you should have in your paragraph, the one that you would have constructed. Okay, we'll go around the class. First of all, maybe volunteers. We'll ask for volunteers. Anyone would like to start us off by reading what you have got down for that particular question? Rebecca, thank you. Rebecca will read or explain to us what she has got down for that activity, and the rest of us, we will be checking. Once Rebecca has done her or given her answer, then we'll get another person to also give an answer for this particular question. The question again, explain in your own words scientifically how it is believed that the Earth was formed. Rebecca.
My explanation is the solar system began as a rotating dish-shaped nebula, a cold diffused molecular cloud of gas and dust. The center of the cloud began to contract inward, forming a hot, dense proto-sun. This hot center, the star we call Sun, was surrounded by this cloud of revolving disk that broke into separate circular or spiral movements of air. The Earth in this way condensed into a spinning whirl of matter. The gravitational attraction caused the whirl to condense slowly through the years to form the Earth.
Okay, very good. An explanation there that is suggesting the condensation theory. Any other student would like to read out what you have found for your answer to that particular activity or question? Bill, how about your answer for that question?
My answer was that Earth was formed when a huge hot ball of gas condensed and cooled as the gas cloud contracted under the influence of its own gravitational attraction.
Okay, good. Definitely he's correct. Maybe a little bit more on what you would have got down should actually sum up your answer to how you think the Earth was formed scientifically. How about Elsie? Your answer for that question?
It is believed that the Earth was formed about 4,600 million years ago, when a star close to the sun, when a star passed close to the sun and pulled a ball of burning gas away from the sun by gravitational force, some of the gases then cooled down after millions of years to form oxygen and nitrogen in the air, while others solidified to form the crust of the earth.
Okay, so what you would have got is similar to what is actually in the book, but maybe your note-taking did not take down every single word from there. Okay, we move on. Someone else? How about Catherine? Your answer for that question.
It was believed by scientists that the Earth was formed by a hot ball of burning gas. These gases cooled slowly and some condensed into liquids to form seas, rivers, etc., while some gases like oxygen and nitrogen remained as gases in the atmosphere. After further cooling, the liquid materials near the Earth's surface solidified to form the outer crust, which we now know as continents.
Okay, thank you, Catherine. Again, the explanation very similar to what the other three students have given. And let's have the last, maybe someone else to read what you have got, the last answer to be given for that question. Ovio, your answer.
The Earth was formed with the rest of the solar system by consolidation of interstellar dust, or in other words, solidifying of the remaining hot dust and gas after the sun was formed.
So is that all you had for when the Earth was formed after the sun was formed? Okay. Again, for those people who have written their explanations, your explanation should at least contain information to tell us the stages in the development of that planet, which is Earth, because it is from the Earth then that we are going to be actually looking at the many features that are formed and the reasons for why those features are actually formed, or the processes which have been involved in the formation of those features. Let's look at the answer from actually the monitor, which is not the answer that you should have, but it is more or less the main ideas that should maybe help you also to double check on your answer. So for the answer to that question, the main ideas now, we can read from the information on the monitor. It tells us that at about 4.7 billion years ago, which is 4.7 GA referring to billions of years, a cloud of gas and dust collapsed in upon itself to form the solar system. And I think a couple of students mentioned that when they gave their answer to that question. Towards the center of that collapsing cloud, a large mass accumulated, contracted under its own gravity, and became sufficiently hot for a thermonuclear reaction to start. It goes on to say that this was the beginning of the sun. Further from the center of the collapsing cloud, smaller masses accumulated by accretion of gas and dust to form the 9 planets that orbit the sun. And because the planets are smaller than the sun and their gravity field or fields consequently weaker, they did not become hot enough for thermonuclear reactions to develop. However, in the case of the Earth, the energy of accretion and possibly giant impact was sufficient to cause melting. And that section, the last part here, becomes important because as we move on to looking at the structure of the Earth, that is when we will see that process really actually shown in terms of the fact that our planet Earth, when we're looking at the structure from the center of the Earth to the outermost layer, is not all solid right throughout. Rather, there are some different materials which can be found which are not of solid form in the different structure or layer of the earth. Okay, we'll come to looking at that in our lesson when we touch on identifying the spheres of the earth. What I'd like us to look at today is to look at the concept or the idea on continental drift. So we are now moving away from the homework. What I have actually gone through and read with you and what was on the monitor was basically what you should have got for your written explanation of how you thought the earth was formed scientifically. So looking at our topic for today, and that is on the concept or the idea of on continental drift. And before we start on looking at the information presented for the idea or the concept on continental drift, I'd like to make reference to our booklet. And the information that I'd like us to look at quickly is on page 2 of our booklet. And the second paragraph, which reads, similarly, in terms of the development of the planet Earth, for hundreds of years, scientists, they have observed the shape of the Earth and tried to explain what they see or what they saw. So the scientists, for over hundreds of years, they've seen the mountains, they've seen the valleys, they've seen plateaus, they've seen rift valleys, they've seen volcanoes, etc. on the surface of the earth. Until recently, no single theory was able to explain satisfactorily most of those features. Over the last 25 years or so, and more evidence has supported a theory which is known as plate tectonics. Scientists had known for a long time that the earth consisted of different layers and that the earth's crust was only a very thin layer in comparison, which was actually floating, that's talking about the earth's crust, on a denser liquid rock beneath. But what was actually missing was an explanation of the actual shape of the crust and the movements that took place. So we will go back now to looking at the idea and the concept of the fact that our planet Earth is actually a zoned planet. And not only that, when we look at the structure of the Earth can be actually classified into 3 or 4 different layers. But prior to that, knowing that information, scientists long time back had already seen that continents were actually moving or shifting. And that's when the development of, or the idea of continental drift came about. So let's look at that concept now. The concept of continental drift. Continental drift is simply an idea or a theory that was developed and that stated that individual continents could shift position on the globe. Think about it. The continents of the world. We have the North American continent, the South American continent, the African continent, Euro-Asian continent. We have the Australian continent. We also have Antarctica. Okay, those continents. Australia, because Papua New Guinea and all the other many little islands within the Pacific, they are not one huge landmass because a continent is referring to a huge landmass. We can only classify that as a region. But Australia is seen as an island continent. It's a big landmass. Similarly, the African continent, American continents, the North and the South America, Euro-Asia. Note that scientists long time back, they also noted that those continents could have shifted or they could have moved. And their positions were not what they were before. They shifted across the globe. So an idea was actually developed, and that idea was known as the continental drift theory or idea. And it simply states that individual continents could have shifted over the surface of the earth over time. Okay, and that's what we're going to look at today. As it happens, most of the supporting evidence was simply undiscovered or unrecognized at that time that the concept of continental drift was being floated around or thrown around. Beginning in the 1960s, data of many different kinds began to accumulate that indicated that the continents have indeed moved. Continental drift turns out to be just one aspect of a broader theory known as plate tectonics. And plate tectonics has evolved only over the last 2 decades. So our understanding of the movements of continents in terms of the scientific evidence surrounding this particular theory is very recent. But prior to that, prior to us knowing about plate tectonics, already scientists long time back did say that the continents did move. But maybe there were not enough evidence to prove to everybody that definitely those continents moved. Okay, we move on. If we looked at the theory or the idea of continental drift, you can now make reference to your booklet. That's on page 3. You would have seen that as early as 1910, a German called Alfred Wegener looked at the shape of the continents and observed that they seem to fit together, particularly Africa and South American continent. So the idea or the concept can go back to looking at the positions of the continent 200 million years ago. 200 million years ago, it was believed that all the continents were one huge landmass, and that one huge landmass was given the name Pangaea or Pangaea, which was referred to as the supercontinent. The position of the continents shifted because about 180 million years ago, that supercontinent then splitted into 2 main land masses. The northern continent, which was referred to as Laurasia, and the southern continent, which was referred to as Gondwana land. That information we've already learned in grade 10. But this is to do with continental drift. The continents did shift or they moved. 135 million years ago, you look at the position of the continents. You could clearly now see the South American continent, and you could also see the African continent. But the other continents are not well developed as we see them today. But that is 135 million years ago. Then we had 65 million years ago. You could really now see clearly the African continent, South American continent. Note separation between the North American continent and the Euro-Asian continent. And also, I'd like you to look at the area which has been shaded in black, because there will be a question that will be asked later on what you think this continent might be. This is 65 million years ago. What do you think this continent would be? Okay, might be Australia. Let's check. Today, as we know, the continents and their shape, and that continent definitely is Australia. But today, you can now really see those continents. The scientists, those people who actually came up with the concept or idea of continental drift, even went one step further, and they did tell us that in 50 million years from today, the continents would still continue to shift or move. And see where the equator is, the line 0 degrees, and see where Australia is. Today we know Australia is not where the equator is, but they believe that 50 million years from today, the continents might also continue to shift, and Australia might sit where Papua New Guinea is today. Any questions or queries on this? Yes? Any questions? No? Okay, if there are no questions, we'll move on. You can refer also to page 4 of your booklet. That particular concept of continental drift was actually brought about a little bit more by the scientist we know as Alfred Wegener. And for any scientist to actually come up with a theory, they will not make assumptions. They must prove to the rest of the world and to the people that there is evidence that surrounds that particular theory. You cannot just say, oh, the world is round. And if they ask you, prove it. Can you prove it? If you can prove it, then good. That's what scientists are supposed to do. If they tell you that the world is round, they have to prove it. They have to give us the evidence so that we believe that the world is round. Similarly, continental drift. The continents are moving, so prove it that the continents are moving. So here goes the scientist Alfred Wegener. He's not the only person who has put the evidence together. There are also other scientists who have actually over those years have come up with a different evidence. But let's base our work on Alfred Wegener and the evidence is compiled or put together. Alfred Wegener had based his proposition of continental drift on several lines of evidence, of which those evidence are the fitting of the edges of the continents. So if you look very carefully at the South American continent and the African continent, and if you did try to put them together, they tend to fit. So he based his evidence on the fitting of at least those two continents. In your textbook or your booklet, that is actually shown on figure 3 or figure 2. When you put the South American continent and the African continent together, they seem to fit. But that's not enough. Do you think people will believe him just by fitting that? It could be a coincidence. So that's not enough. But that is one of the evidence that he looked at. Another evidence involved the similarities of rock types and structures on opposing shores of the Atlantic. So the next thing that he did, he collected samples of rocks along the South American coastline, collected the samples of rocks along the African coastline, and then he found out that those rocks, when tested, were of the same type and they were also of the same age. So that was the second evidence that he brought forward to say that those continents could have been together and they drifted or moved apart. Another evidence that he put forward was that of fossil correlation provided. There were some fossil remains of plants and animals which were found in different continents. Let's imagine dinosaurs. They would have been found in Africa. They're also found in North America. Fossil remains of those. Between Africa and America is a vast ocean. Do you think dinosaurs were very good swimmers? No, they were not. So how do you think they would have gone across to the other side? Perhaps when the continents were joined together, they were easy, or it was easy for them to walk across. So perhaps the continents were together and they drifted apart, and that could be an evidence. So if we did look at some of those evidence as presented by Alfred Wegener, he talked about the shape of the continents first of all, and he said that the jigsaw puzzle, as shown here, fitting South America and Africa, suggests that those continents could have been once joined together and were subsequently separated by the theory or idea continental drift. So if you look at the South American continent, it could have been matched and fitted nicely where the African continent was. So if we did maybe shift this and put it there, you can see the gray color now. This gray diagram illustrates how nicely this particular continent could have fitted with the African continent. Okay, that's the evidence that was actually put forward. The second evidence that I've explained already is that of rocks. Rocks or structure. In 1801, Alexander von Humboldt, a German geographer, noticed that the rocks on both sides of the Atlantic were very similar. So you look at the South American continent. See these rocks here that are in purple. Those are rocks which date back to 100 to 550 million years. Similarly, those rocks were found in Africa and found in this section also of Africa. Then you look at the rocks which are over 550 million years in orange color. The lighter orange, that is. Similarity in South America to Africa. And then the rocks which were less than 100 million years old, further away from where those two continents fitted or matched. Fossil evidence beside the dinosaurs as given. There were also leaves of a distinctive fossil plant which was known as Glossopteris, which were also found in southern Africa, Australia, South America, India, and even in Antarctica. That fossil plant was actually found in all those areas. Imagine Antarctica today. It is an icy continent. You can hardly find plants growing there. But if there is evidence of a plant which is found there, obviously perhaps all the continents were once together in a climatic area which was much more warmer, allowing that plant to be able to grow there. Therefore, evidence is found there. If you look at the fossil evidence of animals, some of those different animals, of which some of them we don't have in Papua New Guinea, but we're looking at North America and South America before the continents were joined, afterwards. This is before when they were joined, the continents, and this is afterwards when the continents actually moved apart or separated. So you can see the isolation of some of those animals in this particular second illustration. Finally, but not the least, the climatic evidence that were put forward to suggest that continents did shift or moved. Climatic considerations also seem to provide support for the theory of continental drift. Many factors determine a region's climate, but a dominant one is latitude. And from what you have already learned in maybe grade 9 and 10, in general, equatorial climates tend to be warmer or a little bit more hotter. And as you move away from the equator, the climate tend to be a little bit more cooler. And you get to the poles, it is actually cold. So what is it with climatic evidence that tells us that yes, perhaps the continents were joined together? In many cases, the ancient climate of a given region appears to have different drastically from the present climate of the same region. For example, there is evidence of widespread past glaciation over India in places where ice is actually unknown today. If we're looking at the Himalayas, which is further north of the continent or further north of the country India, we expect glaciation to be common now because the mountain ranges are high. And the higher up we go, the cooler it gets, snow line, therefore ice is likely to form. But we're looking at the other areas which are lower. And today in India, there is evidence to say that glaciation has actually occurred there. So if that is going to be the case, then one can say that perhaps India was joined together with all the rest of the continents, all the other land masses, and they were all in maybe an area which was cold at that time. And then later they shifted or separated, resulting in evidence being found there today. Moreover, such discrepancies cannot be accounted for simply in terms of global climate changes, for rock records do not show the same warming or cooling trends simultaneously in all continents. So, simply, Wagner's interpretation of climate was that rocks indicating cold climate conditions were deposited when a continent was near a pole and vice versa, and that apparent changes in temperature regime were the result of the continents drifting from one latitude to another. So basically, what we have looked at now are the evidence which were actually put forward by just one of those scientists, and that is Alfred Wegener. Questions? Any questions? Okay, if there are no questions, or if you do not have any questions, then we are going to do some activities now. And the activity that I'd like you to work on will be basically looking at the concept or the idea of continental drift and how the different continents could actually match or could be fitted together. So if we look at the activity now that I'd like you to work on, number one, you have a handout that was given, and on that handout, you have background readings to go together with what we have looked at on continental drift. At the back of the readings, you have the 4 continents: North America, South America, Africa, and Europe. What I would like you to do is I would like you to trace the outline from the pictures. That means for those 4 continents. You cannot cut that out because you have some information at the back. You trace that information on a piece of paper, those 4 main continents as shown. Okay, after you do the tracing on a piece of paper, you are going to cut out following the edges of those continents. Then, after you cut that information, I'd like you to join the continents together so that both sides of the Atlantic meet almost exactly, and you stick that in your exercise book. I'll repeat. The activity that I'd like you to work on. You trace the outline of the 4 continents which are actually on the monitor and in your or on your handout or worksheet. Then you cut out each continent. There's 4 of them as shown there. After you've done the cutting out, then you are going to paste. And when you are pasting, try to fit them so that they are one landmass into your exercise book. And because also the bell has gone, I'm going to ask you to actually complete that work for your homework. Okay, to conclude what we have done so far today, we have looked at the concept of continental drift. When you are doing your note-taking, it is a must that you put into your exercise book the definition to what continental drift is. That's number one. The second thing I'd like you to also include when you are doing your note-taking, the evidence which surrounds the concept of continental drift. And those evidence again are: 1, the fitting of the continents; 2, rocks of the same type, structure, and age; 3, fossil evidence; and 4, climatic evidence. I will also distribute readings here, of which the readings can help you explain a little bit more on each of those 4 evidence that we have looked at in our lesson today. If there are no questions, then class, if you can now stand up. And the keyword to the pilot teacher for our lesson today, which is lesson 19, is fear. Good afternoon, and thank you, class.